Welcome everybody. Thank you for attending. My name is Bernd Zweverink, and prior to working for Maxon, I freelanced for a period of 15 years, and during that time I specialized in modeling, texturing and lighting. In my spare time I continue working on a variety of different 3D projects, some of which are not architecture related. However, today I will explain some of the techniques used to produce the following results. Before I do that, I would like to highlight some of the Cinema 4D Release 17 features which really improve my workflow of architectural visualizations. For example, the all-new SketchUp importer. So when importing a SketchUp scene file into Cinema 4D, the following things are supported, namely selection tags. So that is very helpful when you have multiple materials applied to your model in SketchUp. So these will be imported as multiple materials and texture tags inside of Cinema 4D. UV maps are also supported, so that means that your textures will look correctly, they are applied correctly to your geometry. All cameras that you set up in SketchUp are imported into Cinema 4D as well. The sun position that you set in SketchUp is imported as a physical sky in Cinema 4D. Groups and layers are also supported, so if you organize your scene file in SketchUp using either groups or layers, then you will find these represented in Cinema 4D's object hierarchy and the layer structure. And when I first got my hands on SketchUp, I haven't used it before, and I was able to come up with some results very quickly, so that might be able to tell you how easy SketchUp is actually to use. So I was able to come up with this model that you see here within 3 days' time, without ever having used SketchUp before. So it's a very easy program to get into and to start modeling. And this is what it looks like after I imported the model into Cinema 4D. So as I mentioned before, you can import native SketchUp scene files into Cinema 4D. And I started working on the environment in Cinema 4D because that's a bit easier to do in Cinema than it is in SketchUp. And this is the importer settings that you are greeted with if you import a native SketchUp scene file into Cinema 4D. So as you can see, you can choose to import the daylight system, the cameras, you can skip hidden objects. So if you have certain groups or layers hidden in SketchUp, then these won't be imported into Cinema 4D. And this is a feature that you should always have enabled. It's called split objects by layer, and that simply means that your object layers in SketchUp are imported as layer settings inside of Cinema 4D. So that just makes it easier to select certain elements. For example, you might have all windows in a separate layer, or the wooden logs that you see here in the front. So that just makes it easier to work with your model inside of Cinema 4D. And this is the final visualization that I came up with inside of Cinema 4D. I didn't use any plugins except for two, which I will explain a bit later on, but I used the native Cinema 4D render engine to produce the result that you see here, and a little bit of Photoshop for post-processing. So one of the plugins that I used for this example is the Biomech Edge Shape plugin. So inside of SketchUp there isn't really an option to easily round off sharp edges or to bevel edges, as some call it. And to do that very easily during render time is to use the plugin called Biomech Edge Shape. So what that does is it allows you to automatically create rounded edges during render time, and it's just a shader that is used in the normal channel of your material inside of Cinema 4D. You can then choose a radius for your edges, and the edges are then automatically detected when the image is rendering, and it will create these nice rounded edges, because nothing is 100% sharp in real time. There's always some bevel, and that has an impact on the highlights or the specular reflections, as you can see here. And without it, the scene file looks less realistic. So that's the reason why I like to use Biomech Edge Shade. And it's also very useful when, for example, rendering ArchiCAD, Vectorworks, or all plan models that you import inside of Cinema 4D. So besides using plugins, I obviously also use Cinema 4D's native tools. For example, MoGraph. MoGraph was originally developed for motion graphics, but it can also be used for distributing plant models and trees and stuff like that. So the lawn or the grass was distributed using a MoGraph cloner effect and the shader effector for random placement. So what I did was I created a grayscale bitmap to ensure that the grass would be low or not growing in certain areas. As you can see here, there's less grass growing, and the grass is also shorter where there is less grass growing. So this is realistic as you would expect in real life. And the other thing I did was I adjusted the color of patches of grass using the shader effector as well. So all of that you can do inside of Cinema 4D using MoGraph. Another thing that I did was texture in Cinema 4D, because there are a lot of tools that makes texturing a whole lot easier inside of Cinema 4D compared to other programs. For example, when looking at these logs here, so normally you would have cylindrical mapping for the wooden texture on the side of this cylinder, of this log. But you need frontal mapping to correctly texture the entire log on the front side. So the cap, so to speak, needs to have a different UV texturing format. So normally what you would have to do is to apply a texture individually to the side of the log. You may have to split the cap to just apply a different texture in SketchUp to the front of the log. Or inside of Cinema 4D or Archicad or Vectorworks or Allplan, you would have to create two different textures and two different selection tags just to apply a different texture to the front side and the side walls of the log here. But what I did instead in Cinema 4D is to use the terrain mask for the front side of the log. Because the terrain mask automatically detects an angle for me. So I set a 90-degree angle in the terrain mask. And the fall off that it then creates can be used as an alpha channel. And that allows me to simply stack the cap on top of the cylindrically mapped texture, the wooden texture. And that way I didn't have to create any selection tags. As you can see here, I just have two texture tags. I didn't have to go and select each individual log to apply the texture. I just dragged and dropped it on there, and that's it. So that saved me about 15 minutes of time just individually selecting these logs and having to manually texture them. So the terrain mask is very helpful in that regard, and there are of course many more tricks that can be helpful in this regard. So another thing that I did was use the MoGraph cloner to distribute my grass objects that you see here on the side, so the tall grass. And this is actually just 4 different varieties of the same kind of grass, but I used the MoGraph cloner in combination with the random effector to give each individual clone its own size and rotation. So this can actually save you a lot of time and even money, because imagine that you would have to buy or purchase a lot of different varieties of different grass and plants and trees just to make the scene look natural, because obviously not a single plant looks alike in real life. So MoGraph and the random effector can be used to even make it appear as if one single plant that is cloned is completely different compared to its neighbor. So that's where MoGraph comes in handy as well. And last but not least, I used Laubwerk for the trees in the background. So Laubwerk is a plugin for Cinema 4D that has a large tree library, and it includes trees with all kinds of seasons. So it could be winter, autumn, what have you. So these are all included in the library. They're all textured, pre-made and ready to go, and you can just drag and drop them from a content browser type thing into your scene, and that's it. So these are the plugins and the cinema tools that I use for this specific example. So what are some of the unique benefits of using SketchUp? Well, for one, it's easy to learn. There are a lot of plugins available for SketchUp that are not available for Cinema 3, so that could be a reason alone to have a copy of SketchUp installed, because now you can make use of these by importing the geometry that you create with these plugins into Cinema 3. And I will mention some of these plugins later on. Solid modeling or CAD modeling, so that is not natively implemented in Cinema 3, but SketchUp has a solid modeling method, which basically means that you can very easily subtract geometry from each other. So in this very simplistic example, you can, for example, very easily subtract the sphere from the cube, and you will have the remaining shape then. So that is a different method of modeling compared to Cinema 3. It also has measurements, so if you need to work very precisely, then of course measurements is something very important, and SketchUp can be of help there. Another benefit is the huge library content that is available for SketchUp. So if you go to the website called 3dwarehouse.com, you will come across many different types of content that you can load into SketchUp, and then you can of course load it into Cinema 3 as well. So many textures, but not only textures, also highly detailed models such as the complete bedding system that you see here. And the nice thing is that the content that is available through 3D Warehouse, the website is actually a marketing platform for different manufacturers. So it is in their best interest to upload the latest kitchen models, and you name it, you will find almost everything there. So it's basically a free extended content library for Cinema 3. So I already mentioned plugins, and one of the plugins that I used for the SketchUp example that I showed you earlier was OOB Layouts. And OOB Layouts is a very nice plugin that allows you to very quickly create different types of floor patterns or wall patterns. So you can see here it's a parametric approach. You can choose the gap size, the heights, the tiling pattern, and all that. You can see a representation of what it looks like here. And these are the types of different patterns that you can create with this. And here's just one wall type geometry that was created with OOB Layouts. So this is already slightly harder to do in Cinema 3. You could do it with MoCraft, but with OOB Layouts it's a whole lot quicker. So again, it's a workflow benefit to own a copy of SketchUp for just combining it with a Cinema 3. Obviously, it's another workflow solution that you can add to your portfolio. You might have customers that work with SketchUp, and you can now tell them, well, I can work with you together because we can now import SketchUp scene files in Cinema 3. So previously you had to use FBX and Collada and combine the two different models because one or the other would have a few issues. But now with the native SketchUp importer, there are no more issues, and you can natively import all your stuff into Cinema 3 without any issues. So what did I use OOB Layouts for? Well, this is the interior of the scene file that I showed you earlier, and I created the floor pattern here. Obviously, I needed a way of texturing this as well, and after importing the floor into Cinema 3, I actually used the fracture object set to explode segments and connect to split these boards into individual floor wooden sections, because currently it is one slab, one geometry slab, but I actually need individual wooden boards to be able to texture it. So the fracture object can be used there. Place the floor object as a child object of fracture, choose explode segments and connect, and then press C or this button here to make the object editable, and then you end up with individual wooden floorboards that you can texture. Now again, there is a shortcut here that facilitates the texturing of all individual floorboards, because currently you would have to drag and drop two different textures perhaps onto this model here, and I needed to find out a quicker method of texturing each individual floorboard automatically. And what I did was I created a Espresso setup. So this is all a bit complex looking perhaps, but the Espresso setup will be shared later on alongside with the recording of this webinar on YouTube, so you can download the setup and take a look at it. But let me explain what it does. So I have a couple of different textures here because obviously a natural looking floor has different types of wooden floorboards. So the floorboards all look individual and they don't look alike. So that's why I needed different types of textures that I had to apply to my individual wooden floorboards. So the hierarchy node here takes all of the wooden floorboards and reads the texture tag that is applied to it. Then the random nodes here and the texture nodes there basically ensure that these textures that you see here are applied to my object randomly and automatically. So I don't have to texture these floorboards myself. It's all done automatically through the Espresso setup. And the nice part here as well is that I can automatically and randomly offset the texture space. So what that means is that basically I can have the same bitmap for each wooden floorboard, but they are offset in either the U direction or the V direction, and that ensures that not a single wooden floorboard looks alike. So if you look very carefully, you will notice that they all look random. So this one looks different compared to the neighbor and looks different compared to this one over here. So basically every wooden floorboard is unique, and the Espresso setup allowed me to do that automatically. As I mentioned, I will share that setup for you so that you can take a look at it and make use of it yourself. So another thing that we added to R17 and that really made a difference was the variation shader. So back in 2006, we were able to perhaps copy one tree, but you would have to manually texture each tree to make it look individual or different compared to the other tree. And we changed that in 2006 by introducing a thing called Cinema 4D MoGraph. So MoGraph with the shader effector already allowed us to provide each tree with a different color automatically. So you could choose, for example, the leaf shader and combine it with the shader effector, and you would then have different leaves for each tree, which of course has an impact on how natural the scene looks. But in 2015, we introduced the variation shader with R17. And what that allows us to do is to not only give all of the leaves of each tree a different color, but the individual leaves can actually have a different color per tree. So a single tree can have thousands of different color combinations for each leaf automatically. Obviously, this can not only be used for trees or leaves or things like that, but also for floorboards or let's say wall patterns and all that kind of stuff. So if you have a mosaic pattern, you can even do mosaic patterns automatically using the variation shader. So this is just one example that I created, an autumn type looking tree. So the settings that I used here is to use the polygon variation set to the mode polygon. So what that means is that I can indicate the amount of polygons that are used in each leaf. So in this case, all of my leaves will consist of 4 polygons, and that tells the variation shader that it should texture 4 polygons with a different random color only. So it takes each individual leaf and it basically creates a random color variation in between this color, so the basic texture, and the secondary color. So in between this color and that color, it will randomly color all of my leaf textures here. So that gives the appearance of different colored leaves in a single tree. And obviously that's all done automatically, which is very nice because it saves me a lot of time creating natural looking scene files. Now here is another example. So it's similar to the wooden floor that I showed you earlier, only this time I'm not using any Espresso. And a tutorial on how to recreate this type of wooden roof structure can be found on cineversity.com. So if you go to cineversity.com later, and type in variation shader in the search field, you will be able to come across a tutorial that explains how to create this. But let me explain the settings here. So what was done is you load in a base texture as a bitmap here in the variation shader. The variation shader is placed in the color shader. And the only additional thing you have to do is to set the object again to polygons. And we know that each individual wooden board has 24 polygons. So that tells the shader the size of the object, so to speak. And then on the grading variation, you can actually choose a slightly different contrast and gamma, hue and saturation for each individual floorboard. In addition, we can also offset the UV coordinates, so we can shift these by 1, for example, and we can flip the texture for each individual floor tile or roof tile by enabling UV flip X and Y. So that gives the appearance that each individual wooden tile is completely different compared to its neighbor. So again, it's automated color variation, which makes the scene look more natural. So another thing that we added in R17 is the take system. So imagine that you've modeled and textured the entire thing and your customer is asking for a white model render. So previously you had to remove all of your textures, which takes quite a lot of time actually, and you would have to apply a different texture, a white texture, to the model yourself. But now with the take system, you can actually choose a custom material for all of your geometry, but, and this is different compared to ArchiCAD and Vectorworks, you can actually choose to exclude certain textures. For example, in this case, I chose to exclude the sky texture, so I have a white model render, but the sky background is unaffected. So this gives you a little bit more flexibility in the things that you want to adjust with your white model. It might, for example, also be that you want to have transparent windows. So in that case, you simply drag your glass material in here, and that will make sure that you have transparent windows, but the rest will then be the white model texture. You can also choose to preserve the diffuse color, the luminance, the transparencies of textures and all that. So a lot of flexibility with this system. So you can find this setting in the render settings. It's called Material Override. So now the next example is a recording. So it might be that due to this being a live stream that some of the footage is very choppy. There is nothing we can do about that, but obviously we will make the recording of this webinar available later on YouTube so that you can take a look at it if the performance on your end is on the low scale. So if you see any stuttering, don't fear, we will make everything available on YouTube later on. But the take system, so what you can also use it for is to very easily create different states of an interior or exterior. For example, you might have a customer that wants to have different types of interiors, different types of sofas or floor textures or whatnot. So in the past you would have to texture that manually and maybe save 2 different scene files, but now you can do that all in a single scene file in Cinema 4D R17. So let me show you quickly how this is done. So first enable auto take, so that will automatically record changes in your scene file, and in this case I'm going to create a take for a chair and a sofa interior. So I can simply make the sofa or chair visible for one or the other take. So I can now already switch back and forward between the 2 different takes and switch between the 2 different interior elements. I can do the same with textures, so I can record changes to the texturing that I do in Cinema 4D. For example, instead of a wooden floor, I can have a concrete floor. So select the concrete take, go to the floor geometry, and in this case exchange the texture, the wooden texture with the concrete texture. And you can even change the U and V tiling if these are incorrect. And now that will automatically be recorded. I have to do the same for the sofa interior. And now I can change in between 4 different takes of my interior very quickly and very easily. So this is a very handy way of showing your customer basically different types of interiors or exteriors, and you can very easily, as a landscape artist, change between different plant models, and all of that can now be done in a single scene file instead of several. So it's a very nice way of presenting your scene file. Lastly, I would like to mention that you can also push this to the render queue. So if you have different interior styles, so to speak, you can automatically render these using render queue as well. Okay, so let's move on to the general Cinema 4D Studio demo. So I will explain more in depth on how to use Cinema 4D MoGraph for plant distribution and some additional things. So let's take a look. So MoGraph is something that I already mentioned in the past with the SketchUp example, and the grass example that you see here was also created using Cinema 4D MoGraph, which is essentially an advanced cloning method inside of Cinema 4D. Some more examples of what you can use this for. So it's very useful for creating realistic landscapes. And some of these assets are also included in the content browser of Cinema 4D. This is the example that I will be talking about, and I will be highlighting some of the techniques that are used here to create this example. So I use Cinema 4D MoGraph for the lawn striping. I created color differences automatically using MoGraph, and I also use that technique for the walk path that you see here. So you might notice that each individual walking path, concrete element has its own color. The plant distribution here on the right was also done with Cinema 4D MoGraph, along with the plants that you see here in the background. For those interested, the ivy was grown using a plugin that is available for Cinema 4D for free. So just Google for it. It's ivy grower plugin for Cinema 4D, and it works really great, as you can see here. But let's go ahead and take a look at some of the techniques used in more in depth. So suppose that you want to distribute these plant models naturally across your landscape. So normally that would be a difficult task, but in Cinema 4D you can simply add a MoGraph cloner object and drop your plant assets underneath the cloner object. Now by default the objects are cloned into a linear direction, as you can see there, and we have to change that to objects. Okay, so then you have to ensure that you have render instances enabled, because that will reduce the total amount of memory used. So we will be cloning a lot of plants, and enabling that option will simply reduce the memory used. Align clone has to be disabled, and then we can drag and drop the landscape object in there, and you can see that it's already distributing my plants on top of each vertex or point of my landscape. We have to adjust that to surface instead, and then we can increase the clone count. And it already looks pretty good, but we have to randomly sort through my assets. So set the clone mode to random, and that's already a pretty good looking result, but each plant still looks identical. So what we have to do then is to select the cloner objects, go to MoGraph effectors, and add the random effector. And now we can give each plant its own random rotation, and we can also give it its own size. So as you can see, it already looks more natural because every plant now looks unique. We can of course adjust the landscape in Cinema 4D later on as well, and the cool thing is that the plants simply keep following the landscape. Of course the plant count can be increased at any point in time, but that has an impact on the viewport performance in Cinema 4D. So in order to keep working with the model in Cinema 4D, we have to do one additional trick. We have to apply a display tag to the cloner object. From there we can reduce the level of detail, so that will reduce the clone count shown in the editor, but it will not affect your render. And in addition, we can actually change the display style to box, which will simplify the geometry that is displayed in the editor. And there you go. So now the viewport performance is up to speed again, and we can continue working on the scene file without any problems. So what if you actually want to restrict the growth of the plants? Can you do this in Cinema? Yes, you can. MoGraph, shader effector, and from there you have to enable the visibility checkbox in the parameters. And now you can actually load in any grayscale bitmap, for example the checkerboard shader, to restrict the growth of your plants to a certain area. So you can use any shader, procedural shader, and you can instantly see the result inside of the editor. So there's no guesswork as to what it looks like. Of course, you can adjust the display style at any point in time to get a more accurate preview of what it all looks like. So as you can see, Cinema 3 is highly versatile when it comes to landscaping, and of course this can also be used for car parking lots and you name it. Even concrete fences. So what if you want to distribute this concrete element across the spline there? Well, you can do this using spline wrap. So I've got a cloner setup set to linear, and then I can simply enable my spline wrap to ensure that the concrete elements follow my spline precisely. But I can also give each individual element its own height using the step effector. So you can see, as soon as I load the step effector, each element already has its own size. But you can very precisely determine the height of each element by adjusting the spline graph there on the right. So by control clicking, you can add points, and you can actually adjust the height of each individual element yourself according to your preference. So that's just one other example of the diversity of Cinema MoGraph. So using the random effector and disabling position, but enabling the color mode and choosing a custom alpha strength, we can actually give each individual concrete element its own grayscale color. Just to make it look a bit more natural, we can of course apply a texture to the concrete element, in this case a concrete texture with a concrete bitmap. And if we then open up the concrete texture, we can open up the layer shader, and we can multiply the random grayscale bitmap using the color shader. We can set it to multiply just like you would in Photoshop. And as you can see, now each concrete element has the random grayscale color multiplied with the concrete bitmap. And that just makes for a slightly more realistic scene file, because now each element has a slightly different color. So these are some of the techniques that I used for the scene file that you see here. So the random color variations were used for the grass patches that you see here. So I used the random effector to give each individual patch of grass its own color, so to speak. I used the color or shader effector to create the lawn striping that you see here. And I also used the spline deformer to create the path, the walking path, along with the random effector to give each individual concrete slab here its own grayscale color. So these are the techniques that I use in almost all of my visualizations, and it really saves a lot of time in my case, because most of the stuff is automated, so I don't have to worry about it. And using any other solution, I would spend, I think, weeks more time to just produce a decent looking lawn like you see here. So I already received questions in the past. Well, how did you create the grass shader? Because it looks very realistic. The grass shader will also be made available later on in YouTube. But let me explain some of the settings that I'm using here. Apologies. So the magic basically happens inside of the luminance channel. It looks very complex, but you can already achieve a very good looking result if you simply have the bitmap of the grass inside of the luminance channel and multiply that with the backlight shader you see here. What the backlight shader does is it allows light to pass through an object, and if you have an object in front of the grass, for example, that is casting a shadow, then the shadow will be visible on the opposite side of the grass. So that causes and creates very realistic lighting when it comes to the grass in sunlight, for example, that's partially blocked by an object. You can see the result here in the shader preview as well. So there is a donut type shape on the other side of this object here, and you can see that the light is passing through it, but a shadow is being cast on the front side, even though the object is on the opposite side of this plane object here. So that is what makes the grass look realistic. The other thing that I did here, which is slightly more advanced, is to apply a different texture to the front side and the back side of my grass object here. And I did that with the normal direction shader. So the normal direction shader basically detects the front side and the back side of my grass blade, and I can use that as a layer mask for the rest of my textures above it to apply these textures to either the front side or the back side of my texture. So that's done by using the normal direction shader, and that is basically all I had to do to create the realistic grass. And I also used the same texturing approach for leaf textures when it comes to trees and all that. Even for curtains, for example, I also used it for curtains because they are also translucent, just like grass. So this is the general approach I used for that. But don't worry, I will make the scene file available later on, the grass scene that you saw earlier, and you can analyze it and pull it apart and use it yourself as you wish. So Cinema 4D MoGraph can not only be used for plant distribution or creating building elements, but it can also be used for animation. So I was given the challenge to animate a lighting system, a very unique lighting system that was created by someone named Francesca Rogers. And the system works in a way where you can unfold these individual flaps by hand. You can see it here in the back as well. So these unfold and they will reveal a light underneath. So you can create some very interesting looking patterns, but how would you actually show a customer how this works and what the impact is on your interior, what it looks like? How would you do that? So how would you animate these flaps? Would you do it by hand, or is there some other way of doing it? Well, if you own 3D Max or Maya, you would probably do it by hand because there is not an easy way of automating that, but in Cinema 4D, luckily, there is. So this is the final result that I was able to come up with, and the animation is actually triggered automatically and dynamically. So I didn't have to hand animate all of the individual flaps. That is all done automatically, and this is the setup that I used for it. So again, it's MoGraph that comes to the rescue. So what I did was I modeled these individual flaps that can open. And you can see the arrangement here. So I have one plane object. So the plane object is one individual flap that can open. I added a hinge or a connector, just like in real life. So basically you are recreating real life. So the connector is basically a hinge here on the side, and the motor is then opening the flap automatically. So it's basically a motor driving a hinge that makes the flap open. And the smart thing here is that you can actually use an emitter, so a particle emitter, with a spline, with a sphere. And the sphere is dynamic, so it has a dynamic stack applied to it. And as soon as the dynamics object or the sphere hits one of these flaps, it will automatically trigger the motor. So it will trigger the dynamics animation. So instead of hand animating each individual flap, the dynamics system and the emitted particles are actually automating the animating process for me, and it took me literally just 3 minutes to animate and model the entire setup, and that was it. I was done creating the entire setup. Okay, so let's move on to some of the lighting techniques that I use for my interiors and exteriors. And sadly enough, we are not at the point that there is a reality button on your keyboard that you can press, and presto, you've got a realistic looking interior or exterior. So there is some work involved in creating realistic interiors and exteriors, but thanks to Cinema 4D, and a unique feature which is only available in Cinema 4D called light mapping. Interior lighting is a whole lot more, is a lot easier than you might imagine. So this is a scene file that was created by one of our beta testers, and his name is Alberto Blasi, and he made use of light mapping. And light mapping is basically a method that allows light to bounce around in your interior scene file many times. So with older methods that are also available in ArchiCAD and Allplan and Vectorworks, it's feasible to have light bouncing around in the interior for perhaps 2 times. But in reality, light actually bounces around many times more. So it's basically an infinite amount of times that light can bounce around. And that is very time consuming to calculate. So if you would increase the light bounce count, so to speak, in any of the other programs, the render time would shoot through the roof, so they would become very high. But in Cinema 4D with light mapping, we can have a diffuse depth of maximum of 128, and the render time would still be very low. So this is a unique method of calculating global illumination or natural looking lighting. So let's take a look at what is possible inside of ArchiCAD or Vectorworks or Allplan, for example. So the global illumination method available there is called irradiance caching, and as I mentioned before, a diffuse depth of 2 or lower would be feasible due to the render times. So the render time for this scene file in any of the CAD programs would be around 32 minutes or perhaps even higher on my machine. And there are already some issues that we have to solve in this particular interior. So you might notice that the contact shadows are almost absent, so they're missing. So underneath the bed over here, there is not really a good contact shadow, and the carpet seems to be floating mid-air because there is a missing contact shadow around the edges of my carpet. Similarly, the shadow around the staircase is not really very well defined. There is one way of fixing that in Vectorworks, Allplan, or ArchiCAD. You can use a global illumination method called QMC rendering. But as you might have noticed, I had to decrease the diffuse depth, so the amount of time that light bounces, in order to match the render time of my previous scene file. So right now we are at 35 minutes render time compared to the 32 minutes of the previous scene file, and the scene looks a lot darker because the light is only bouncing around 1 time, but the contact shadows have been improved. So you can see here the contact shadow underneath the bed is now well defined. The carpet no longer seems to be floating in midair, and there is a good contact shadow now for the staircase, but the interior is now very dark. And if we were to increase the diffuse depth to create a brighter and more realistic interior, the render time would be increased from 35 minutes to perhaps 40 to 50 minutes or even longer. Now, inside of Cinema 4D, we can actually combine QMC, which is normally at least the slower global illumination method, with light mapping. But inside of light mapping, we have an option called radiosity maps, and that actually reduces the render time of QMC rendering. And I have a maximum diffuse depth of 32. So light bounces around 32 times, causing the realistic looking and natural looking interior illumination. But the render time, despite of using QMC with the increased and better looking contact shadows, Despite of all that, the render time has been reduced by half to just 16 minutes compared to 35 or even higher using any of the other methods. So keep this option in mind. It's called QMC in combination with light mapping, and that will produce the superior results with the reduced render time inside of Cinema 4D. And it's basically just enabling two options in Cinema 4D, and you can make use of the better looking interior lighting with the better looking context shadows. So just a comparison side by side. So Cinema 4D on the left side with CineRender, which is implemented in ArchiCAD, Allplan and Vectorworks on the middle and on the right. So you can see the render time is reduced and it looks better. Obviously, and this has an impact on interior animations or exterior animations as well. So if you have to render an animation, obviously then time is of the essence. You want to spend the least amount of time rendering your interior. And what I did here is I try to match the render time of CineRender, or the render engine that is implemented in Vectorworks, ArchiCAD, and Allplan. I try to match the render time of CineRender with the one that is available in Cinema 4D. So on your left side, you will see Cinema 4D with light mapping and QMC and radiosity maps enabled. On the right side is QMC rendering, which is a lot darker, but you can also see that there is a lot of noise in this render. And that will show up in the animation as well as noise that is jumping around, which is very distracting. And let's take a look at the animation. So this will be choppy, but again, we will make it available on YouTube later on. So you might have noticed that during the animation that the noise is jumping around, which is very distracting. And even though we have a more natural looking lighting in Cinema 4D on the left side, we were able to come up with a reduced render time and a higher quality compared to CineRender on your right. So that is another benefit of using light mapping, just the ability to quickly render flawless animations without any flickering or artifacts like you see on the right side. So I mentioned already that it's just enabling a couple of options in Cinema 4D, and then you can make use of the enhanced rendering capabilities. What you have to do is go to Render Settings, Global Illumination. Make sure that you have your primary method set to QMC rendering, your secondary method to light mapping. Then you have the light mapping tab here. And inside of the light mapping tab, the only thing you have to do is to enable build radiosity maps. So that option speeds up QMC rendering, and that light mapping option gives you the enhanced diffuse, therefore the enhanced global illumination. So you can increase that from 16 to 128. But what I found out is that 16 already looks very realistic, and you don't need to go higher for realistic looking interiors. So that's the only thing you have to do. Enable light mapping, QMC, and radiosity maps, and that's it. So you can leave everything else alone, and that will already give you improved results inside of Cinema 4D. But what about materials? So Cinema 4D's material system is more advanced than you find in CineRender, and one of the reasons for that is our enhanced reflection system. So the kitchen scene that you see here makes extensive use of the enhanced layered reflections that we have inside of Cinema 4D. So you may notice that there are scratched materials, brushed metals, so to speak, the oven knobs here, and the front plate of the oven all consists of brushed aluminum, as well as the tiles that you see here on the back. And actually these tiles were also distributed using Cinema 4D MoGraph. I imagine you guessed it already. You can see that there are slightly different colors, slightly different patterns to it, and all of that was again automated using Cinema 4D MoGraph. So extensive use of Cinema 4D's multiple reflection layer system. It can not only be used for brushed materials, but also for things like carbon, metal flakes for car paint, for example, and another example of brushed aluminum. So that is all possible inside of Cinema 4D using the multi-layered reflection system. However, I will focus on one example, namely the oven knobs here. So how do you create these oven knobs very quickly and easily? So inside of Cinema 4D, double click to create a new material. And inside of there, you will find all of the channels that are also available in ArchiCAD and some of the other CAD packages. But what we are interested in is the reflectance channel inside of Cinema 4D. So delete the default specular layer, and from there you can actually add multiple reflection layers of different types. But we are interested in the anisotropic shader, reflectance shader, and that is the brushed aluminum shader that we have inside of Cinema 4D. As you can see, we have previews inside of the editor, so you can see what you are working on and how each change affects the preview. And we have to enable the anisotropy scratches in this case, because we are interested in creating a scratched material, so enable primary scratches. And we need a radial pattern, so the reprojection needs to be set to radial. And as you can see, currently the radial pattern is not at the center, so we have to make sure that the offset in the U and V direction is 50%, and now the radial pattern is at the center. We can also increase the contrast of these scratches by changing the primary amplitude to 200%. The reflection strength can then be adjusted from 100 to 50%. And that's it. Now we already created the material, so we only have to apply that to the oven knobs. In this case, a simple cylindric shape. And we have to change the projection from spherical to flat projection so that we can accurately place the radial pattern at the front side of our buttons. And that's basically it. So now we can render it using Team Render, for example, so that we can very quickly render those results. And as you can see, that's it. We already created some realistic looking oven knobs. So that's how quick and easy the system is once you get used to it. So some of you might be wondering as well about the render times of Cinema 4D. Well, 60 minutes is something that you already mentioned in the past. 60 minutes is possible for a very realistic looking interior. But what if you are working on an animation or you want to render stuff faster using multiple machines? Of course, there is a way of doing that inside of Cinema 4D. So we have, which is part of Cinema 4D, program called Team Render, and Team Render can be accessed either inside of Cinema 4D or externally, which I will explain a little bit later on. But basically what that allows you to do is to hook up several computers, could be either Mac or Windows PC, and you can use these machines to aid in the rendering process of either still images or animations. So in the past, with previous versions of Cinema 4D, I think 2 years back, you were only able to render animations with Team Render, but now you can also speed up the rendering of a single image or a single frame. So we have automatic client detection, depending on firewall settings, of course. So computers that have Team Render enabled will automatically show up in Team Render, or you can enter the IP addresses or the network name or computer name to add each individual client to your team, so to speak. Another thing that we have is Team Render Server, and just to quickly explain that, Team Render Server is a separate executable that you can launch, and that allows your customers or employees, for example, to log in and to render their scene files if they want to. You have management systems in there, user management systems, so you can prioritize certain scene files which need to be rendered first, etc., etc. So all of that can be done. Okay, so moving on to another thing that I often use for my interior assets and even for landscaping inside of Cinema 3D. It's the sculpting capabilities that we have. So in this case, I often use it for couch modeling and things like that. So sculpting, we have a lot of presets to make it easier to work with sculpting inside of Cinema 3D. We have presets for things like seams. So you can see that already here on the front side of the couch. For creases, for folds, for fabrics, rivets and bolts, rocks and bricks, and floor patterns, and many more things. So sculpting is typically used for adding additional details like these things here mentioned on the left to objects. As you can see here, I went from a very basic model to a highly detailed model using the sculpting tools inside of Cinema 3D. But let's take a look at the couch example and see how easy it actually is to add additional detail to it. So what you normally do is open up the content browser. And in this case, I want to add some stitches or seams to my model. So you simply select one of the presets. And in this case, use the steady stroke, which means that I can very quickly draw straight lines. And that's it. So I can already add detail to my couch model by just selecting a preset and quickly drawing a couple of strokes. And then by using the pull brush, I can very quickly add some indentations to make it look even more realistic. And of course, the other tools like grab can be used to move around the geometry and to display it very quickly to create a more realistic and natural result. Of course, it can also be used for landscaping. So for realistic landscaping, grounds, etc., we have presets for that implemented as well. Or if you have to create realistic wall patterns. So all of that is created very quickly using the presets inside of Cinema 4D. But basically you can use any grayscale bitmap or grayscale photograph to create these type of patterns. So you are not limited to the presets that we have. You can load in different bitmaps even from programs like Mudbox or ZBrush. You can load these inside of Cinema 4D. And you can make use of these as well. So there is actually another way of speeding up rendering with performing a few tricks. This is very beneficial if you don't actually have to remodel the entire building in 3D. So in many cases, if you have to work on the environment of a building, for example, you want to show a certain garden design, so landscaping design, or you want to show a customer what a swimming pool looks like in front of the building, or what the building looks like with an additional window. So I take it that normally you would actually recreate the entire building in a 3D application. A CAD application like ArchiCAD, Vectorworks, and Allplan, but that's actually not really necessary in Cinema 4D because you can turn 2D into 3D inside of Cinema. And just to highlight where these type of things were used, so if you look at movies, like for example Lord of the Rings, so many of the villages and cities that you saw in Lord of the Rings, they don't really exist in real life. And to speed up the process of shooting the movie and creating the movie, they actually perform a very similar technique, turning 2D into 3D. So what they do is they actually paint the villages. That's called matte painting. And they project those paintings onto very simplistic geometry, and that makes it appear as if the village actually exists. And that is the same technique that we can apply inside of Cinema 4D, and that's called Projection Man. So Projection Man was actually developed by Maxon for Sony, for the movie industry, and it can actually be very beneficial for architecture as well. So as I mentioned, I wanted to show a customer what this building looks like with an additional swimming pool and with an additional window, perhaps some plants here. I grew some ivy here on top of the building, but I didn't recreate the entire building in 3D. So this is still the photograph that you saw earlier, but adjusted with 3D elements. And the very nice and cool thing is that I can even turn this into a complete animation. So I turned the photograph into a 3D animation, as you can see here. So how does it work? I don't really have the time to explain it all in depth, but I will send you all an email asking you what topic you would like to see in more detail, and I will then organize another webinar to explain these techniques more in depth. But let me explain it quickly how this works. So this is the photograph that you saw earlier, and I projected the photograph onto very simplistic 3D geometry. So this is just a cube that I extruded a couple of times. So the extrusion and the modeling of this thing took perhaps 2 minutes, not more. And I then project the photograph from a camera's point of view on top of the geometry. And this is then the result that you get. But you might, of course, imagine what happens if you create an animation out of this, because the photograph or the camera didn't see all of the details. So if you have a camera move from here till here, and you see part of the top of the building here, for example, then of course you have missing information. You can already see that the photograph didn't really capture the information here, and if I move my camera upwards, there is simply missing information here. So without Projection Man, there is no easy way of solving this problem, but with Projection Man, we can actually fix this problem. And you can already see that there is a second camera here, so not only a camera that is represented here in my current point of view, but there is a second camera up here. And what Projection Man allows you to do is you can render out the render with the flaw that you saw earlier here in the corner. You can send that to Photoshop automatically using Projection Man. And in Photoshop, you can then use the projection or the clone stamp, for example, to fill in the missing information that you would normally see. If you then press the Save button in Photoshop, it will automatically update the textures in Cinema 4D, and the problem that you saw earlier will then be fixed inside of Cinema 4D, and you can then create a full-blown 3D animation out of this within a few minutes. So this saved me the time of recreating the entire building in 3D, because I only created the front side that is visible to the camera and nothing else. And I just added the 3D elements later on, like the window that you saw and the swimming pool in 3D. And the other cool benefit of this is that you don't have to recreate the lighting inside of Cinema 4D, because the lighting is already included in the photograph. As you can see here, this is just a viewport render without any of the shading or lighting applied to it. And because of all the information is already included in the photograph, I don't have to use global illumination. I don't have to worry about complex shading setups. I don't have to worry about recreating the realistic looking result because it's just a photograph that is turned into 3D inside of Cinema 4D. And global illumination and calculating shading always takes time in Cinema 4D. And because I'm using a photograph, I am able to render each individual frame of this animation in just 10 seconds. So earlier you already saw that I was talking about render times of 60 minutes and perhaps even higher. But now I can render an animation just 10 seconds per frame, and that saves me a lot of time when working on things like landscaping. If I want to show an extensive garden, etc., this saves me a lot of time because I don't have to worry about texturing, I don't have to worry about lighting, it's all implemented in the photograph. So that saves me a lot of time. So if you are then a bit more advanced in these kind of techniques, then you can even recreate entire cities inside of a 3D application very easily. Again, I would have to emphasize that this is a live stream, so the animation will not be very smooth, but at least I will be able to show you what the full capabilities are of Projection Man and how it is used perhaps in the movie industry. So this is a very good example. So the entire city is basically a background photograph. So all the buildings that you see in the background here, these are photographs. The clouds are actually a movie that is projected onto a separate plane. And let me just show you. The buildings in front here are actually just cubes. Very simple cubic geometry. So here's the setup behind the scenes. So you can see the geometry there, very simple. Even the trees are just blobs or spheres. And the photos are then projected onto the geometry. And inside of Photoshop, the missing information is filled in using the clone stamp. So you can already see all cubes and very simple geometry which defines the entire scene. So if you have your own flat, for example, you have your own design and you have to build that into a complex city, you don't have to recreate the entire city if you're using Cinema 4D. You can just use a photograph from a certain perspective, and then you can place your own flat building or apartment in there without having to recreate the entire environment. So that will save you a lot of time in these type of extensive scene files. So almost at the end of our webinar, and I would just like to highlight some of the other benefits inside of Cinema 4D. One would be cloth dynamics. So if you have to throw a cloth on top of a table, for example, or you have a cloth hanging from a ceiling, you can very easily do that using Cinema 4D dynamics. We have accurate OpenGL surface material previews. It's a mouthful, but basically that means that in the editor, so the working environment of your application, the materials that you apply to your model actually look realistic in the editor of Cinema 4D. So when you are rendering, it actually looks very similar to what you see in the editor, so there's no guesswork as to whether your brick texture was placed correctly or if your procedural texture was placed correctly. You will see that directly in Cinema 4D itself. Easy decor placement, so if you have things like logos that need to be placed on the wall, you can very easily move these around inside of Cinema 4D. With the texture tools that we have enhanced additional modeling tools that are very suitable for organic shapes and a lot of deformers that you can use to form your geometry, even the stuff that you import from the CAD programs. We have very good animation capabilities, some of which you already saw with the MoGraph example that I showed you earlier. We have thousands of high quality assets in our content library. Things like kitchen elements or trees, plants. You can find all of that inside of Cinema 4D, and the library is extended each and every year with high quality, very good looking assets that you can use for interior and exterior rendering. There are a lot of third-party plugins available for Cinema 4D as well. I already mentioned Ivy Grower, so that's something that I very often use in my architectural renderings. Laubwerk for huge amounts of tree presets. So digital elevation model data that you can load inside of Cinema 4D. So this is basically data that you can download from Google, and you can very easily recreate entire cities and landscapes using that kind of data, because even building height information is included in the DEM data. So it even allows you to create a city with a press of a button. There is again a tutorial on Cineversity that I highly recommend taking a look at. I think it's Philadelphia, I'm not entirely certain, the city that is being rebuilt there using digital elevation modeling data. So I recommend taking a look at it. Another thing that you can do inside of Cinema 4D is crowd simulations, so people walking around and interacting using a plugin named Anima. 3D printing is another thing that we support. So most of the slicer programs that will build the data that a 3D printer understands, they will support STL files that are exported from Cinema 3D. And these STL files even include bitmap information. And that means that you can even print color in your 3D printed models as well. So these are some of the additional benefits of Cinema 3D. I hope that you enjoyed the webinar, and maybe you have some questions that you would like to ask, and I will do my best to answer them right now. So yeah, go ahead. If you have any questions regarding any of the examples that I showed you earlier, just ask the question and I will do my best to answer them. You can also send me an email later on. You should have my email address. It's j_Zweverink. It's a bit difficult to spell perhaps, but you should have received an email in the past for the invitation, for example. So if you have any question, you can send me the questions through email as well. All right, thank you for attending. As mentioned before, we will make the webinar available later on YouTube, as well as the individual scene files that I talked about, like the grass scene and the grass material. So make sure that you take a look at it later on. And yeah, maybe see you until next time, until the next webinar. Thank you for attending.